Good morning, ma'am. Shall we start in?
Hi, Jayanti. I am getting some echo sounds or something like that. I couldn't hear you clearly. What you said now? Please repeat.
Sorry. Good morning, ma'am. I can't hear properly. Shall we start the meeting?
Yes. Yeah. Sure. Start.
Okay, ma'am. Okay. I would like to invite Miss Veena from third year student to invite the chief guest.
Good morning to everyone. Good morning to everyone. It's my great pleasure and honor to introduce our esteemed chief guest for this enlightening webinar session on recent trends and opportunities in core industries. The insights we are about to receive are sure to inspire and guide us in navigating the dynamic landscape of core industries. Allow me to introduce Mrs.G. Vaishnavi, a remarkable professional who has not only excelled in her field but has also become a source of inspiration for aspiring engineers and professionals alike. Mrs. Vaishnavi is an accomplished alumna of the Electronics and Communication Engineering Department at the renowned National Engineering College. Her journey from being a bright student to become a senior developer at Cisco Systems Bangalore is a testament to her dedication, expertise, and unwavering commitment to excellence. With a profound understanding of the ever evolving technology landscape, Mrs. Vaishnavi has positioned herself at the forefront of innovation within the core industries. Today, Mrs. Vaishnavi brings her wealth of knowledge to his virtual platform, ready to shed light on the recent trends and opportunities that shape the core industries. It is an absolute privilege to have Mrs. G. Vaishnavi as our chief guest for this enlightening webinar. Let us welcome her with the utmost respect and enthusiasm as we eagerly anticipate the valuable insights she is about to share. Thank you.
Thank you so much for your welcoming notes. And Jayanti, shall I start with? Okay. Let us start.
Yes, ma'am.
So I have put some slides. Maybe not much deep because I didn't have much time to put slides, but I have put some slides. So let me share my screen and start with. Just give me 2 minutes. Sorry guys, some problem in sharing my screen. Just 1 minute. I'll. Can you see my screen now?
Yes, ma'am.
Yes, ma'am.
So you are able to see the presentation, right?
Yes, yes, ma'am.
Okay, good then. Now, is it able to be screen in the full screen or like how is it? Hello, students, can you hear me?
Yes, ma'am.
I don't know. Like I am just doing as a slideshow. Are you able to see the slideshow, or is it like fine be with like this only? Are you able to see the slideshow?
Yes, ma'am. But to send the presentation mode, can you please give the F5? Then it will give the whole presentation.
Okay, then let me share the entire screen. I thought not to share the entire screen, and I was sharing only one window. Maybe
Okay.
problem because of that. Mm,
Okay.
I'll try to share the entire screen. It's okay, fine. Because
Okay,
of
ma'am.
confidential issues, I don't want to share the entire screen, but still okay.
Okay, ma'am.
Okay, now what's happening, guys? Able to see my complete laptop? So I think it should be.
Ma'am, ma'am, now you can select the presentation slide, presentation icon.
I am already
No,
presenting.
no, no, ma'am. It shows the blank screen.
It shows blank screen, huh?
Yes, ma'am. Okay,
Uh,
okay. What?
okay. I don't know why there a problem. Okay, so
Ma'am, better you can give the appear screen option and choose.
this is
Yes,
fine.
ma'am. Yes, ma'am. Fine. Yes, ma'am. We will start, ma'am. Yes. Yes, ma'am.
Uh,
It's clear to.
actually, is it getting changed? But okay. So 1 minute. This Mac has some issues, man. Okay, fine. So are you able to see now?
Yes,
Is it
yes,
moving
yes,
on?
ma'am. Yes, ma'am. Yes.
Then fine. Then good. Okay. So let us start with recent trends and opportunities in core industries. Okay, so as just giving, let me give a brief introduction of mine. Like, okay, so I am Vaishnavi. So my native is Satur, and I completed my engineering in National Engineering College BEC 2010 batch, and then I joined Mistral Solutions Private Limited, Bangalore as a software engineer, and there I worked for 5 years. And then I moved on to Pathpatta Technology Private Limited, and there I worked for 5 years. And then now currently I'm working in Cisco Systems since 3 years as a senior developer, and this is my total 13 years of journey. And okay, so to start with, um, ಎಲ್ಲರೂ ಸಾಪ್ಟಾಚಾ breakfast you had everyone?
Yes, ma'am.
Okay, so Recent trends and opportunities in core industries. So if you see, as we know, like as an electronics engineer, people would have said like you can go both with software and with hardware, and electronics engineering will allow us to do both. So that's really true. Yeah. And but that's not only true for ECE, and like many people, irrespective of their domain, can go for both for hardware and software. So that is there. And there is something called embedded software, which is like we can still like not completely out of electronics, but it is a software that we can work on close to the electronic devices and circuits. It's not purely hardware. It's we have to write drivers, softwares, firmwares for the devices, whatever we have, like whatever the projects the customers come with. So in that way, for now, I am put into the platform team. Means what to say? Like I am mainly into driver side. So Linux device drivers like closely related to the hardware. I am closely related to the hardware, and also a little up layers like middlewares and firmwares, but not on the top layers. Like I am not associated with the top layers. So always with the drivers related to the hardware. So now let us start. Still, I'll try to cover some almost everything as per my experience. But okay, so what is an embedded system in today's world? And one more doubt, like now. So now everything is clear, right? My voice is clear, and you are able to see me, and you are able to see my presentation. Everything is clear.
No, ma'am, I think your presentation is loading now.
It's loading now.
Yes, ma'am.
It's not visible there.
No, ma'am, it's not visible.
Okay, I thought it's coming. What is happening? Like so many windows are visible, right? Some problem with the sharing only, man. Yeah. Any issues now you people are seeing? It's better like maybe I can share the presentation over email so that someone else can present. Some problem like it's not at all getting.
Yes, ma'am, now it's visible.
Okay, let us go with this only. Okay, slideshow and these things are not working. So let it be small, and I think you are able to see the screen. Let it be fine like this. Okay. And okay, so what is an embedded system in today's world? So, anyways, everyone knows like now what is an embedded system and everything. So, just start with the presentation. I'm just going on with the definitions. So, as you know, just what is an embedded system? Like, can anyone unmute and just tell me your view of this?
Yes, ma'am.
Yeah, don't hesitate. Just tell me. I don't want to point out names. Please, anyone can speak or just what I don't ask much questions. Just tell me what is your view or like what is an embedded system?
Ma'am, it's an combination of both hardware and software, but not that much welfare about embedded system. That's it, ma'am.
Okay, thank you. Anyone else can try? Not necessary that always Veena should speak, right? சும்மா பேசுங்கப்பா. தமிழ்ல பேசினா பேசுவீங்களா? யாராவது ஒருத்தர் சொல்லுங்க. இன்னும் ஒரே ஒரு ஆள். தமிழ்ல கூட சொல்லுங்க. சரி, பரவாயில்ல. பேசாம நம்மளே பாயிண்ட் அவுட் பண்ணிடலாம். சீதாராமன் யாருப்பா? அனு சந்தியா. சொல்லுங்க.
Embedded system is something which makes a hardware work with the help of software.
Super. Okay, correct. Okay, so embedded system is the definition madri partha. So it's a hardware and software combination based on a microcontroller. So we have said studied about microcontroller, microprocessor, everything. So that is the base of an embedded system, and upon that we can develop whatever we want as per our specific requirements. So for now, as you know, like it is designed to carry out a specific task. So it is like different electronic devices are there, different how to say, like projects are there, like different industries are there. Everyone wants, like maybe someone wants audio but they don't want video, but someone needs video, they don't want audio. Someone needs like camera inputs, like they want like sensors. So you cannot give everything to everyone. So, and that is a waste of money, waste of power, everything. So when embedded system is particularly designed to carry out a specific task either independently, or you can, like that will be a very big larger system, and many embedded devices will be used over there. So it is like this. So as we said, to carry out a specific task, we are designing an embedded system, and that is a combination of both hardware and software. So and firmwares are also used, like because every system needs a memory, and every system needs what to say, some peripherals, like peripheral inputs. Like suppose you want to give an HDMI input, suppose you want to give an RGB input, like video input, audio input. So these many stuffs are there. You want to connect an SD card, or you want to connect an USB. So these many input peripherals also you want. So we have to design an embedded system based upon that. So this is just a basic understanding. I think you will be knowing it already. So let's go into the next one, and one minute. Okay, so now applications of embedded systems. So as we see, as we discussed, like our short range of application, we think like it is useful in the consumer electronics, and but now you will be knowing about at least the defense, medical equipments, and automotive systems. I think you will have little idea on that. And smart devices, mainly you will be knowing it because everyone has smart TV in our homes now. So almost all. So those are all smart devices, like which it will be automatically detecting any Wi-Fi or Bluetooth or any devices nearby, and it will get automatically connected to it. So if it is already done once, so those are all smart devices. And for TV, what are all the inputs do you need? And you need the streaming, and you need like the dish DTH will provide you the HDMI output, and it will be connected to the TV input, and that should be displayed. And you can specify like what are all the resolutions you need for any screen, and what are all the settings. So those are also like, it's not like as simple as what we see outside. So if you want to change the resolutions or settings or everything, there is again going into some particular chips, and where some firmware, some chips, everyone is involved, and finally the software calls goes to the final drivers, and the drivers change the register settings, like okay, now I want this particular this resolution with this coloring or this filtering I need with these settings, and finally it comes again to the processor, to the output, what is it, output parsers, like video parsers that we say in technical terms. Maybe you can assume as the buffers. So like some memory, finally it will come into some memory, and finally that comes to the display. So these many settings are involved when you try to change a single resolution part or anything like that, involves like multiple steps inside. So consumer electronics, as you know, like we have some hair dryers, we have washing machines, fridge, those are also behaving smart now. And IoT devices. So IoT devices, what are those? Are like like Internet of Things. IoT is Internet of Things is designed like so that you can control a device from anywhere, provided if you are connected in the same network. Assume there is maybe some device in some machine or something in a factory. Now the machines are not only mechanical, as you know, like there are some many embedded systems involved in that. So you will have embedded systems, you will have Wi-Fi inbuilt in that embedded systems, and you will have like UI access, like you will get some UI access. I think maybe you people will be having some Wi-Fi routers or everything in your home, which you will be connecting like to a PC. Like you can open a HTTPS web UI screen where you can configure your Wi-Fi routers, password, username, everything. But that will be somewhat wired, and so here what I'm saying is like the similar example, but everything is wireless, and you will get a UI based on that, like some login ID, which is like if you are in a network, you like now everyone is connected through systems. So all your systems will have a particular IP address from your National Engineering College network. So like that, all the machines in the industry will have a particular IP from the from the industry network. And if you are also connected to that network through a laptop, you will be able to access the machine's settings. So from your home, like you can connect to your office network, or you can connect to your college network, like through a VPN connection. The VPN means virtual private networking mechanism. So the VPN, through VPN you can connect to the network, and if you type a particular IP of particular machine, you will get all the details, like the UI, web UI will be loaded. Like if you take some example of like okay, protein synthesizer or something, like machines are there. So there you can see like what are all the input chemicals loaded, like what are all the limits, what are all the like what is the amount of mixing that is done with the chemicals. So like this, the many agricultural machines, like many different machines are there now in the industrial automation sector. So everyone will come up to the software companies that they need some devices, and they will give their input requirements, and they will say you come up with a design with for an embedded device which will do this for us, and finally we should be able to control our mechanical devices as per our requirement. So they will be just asking like if we should be giving an UI also, right from the UI till the drivers or till the down layers, we should give everything to them, and they will just give like okay, I want this value of some chemical and this value of some chemical only to be mixed in, only the allow that much and mix it, and control the machine like this. So we have to come up with those designs, and we have to control like that. So that is called Internet of Things. And medical equipments, I think like everyone has gone to big hospitals, and everyone can see big machines there. Do you think all those are like completely mechanical? No, they are not completely mechanical. They have many chips inside, which is doing their job, so that the signals, infra signals or UV signals, whatever comes inside, how they want it, and how the interpretation of that signals should come in the screen, how the display should be, like those things are designed on electronics only, and not only mechanical. And defense technologies, as you know, like we have different planes, missions, aircraft, spacecrafts. Yeah, and I think even nowadays, even if you see a Volvo bus, like one body are putting tickets and going and coming back, all those buses, everything has the embedded devices in it. Even a small mixer grinder or like Zodiac machines, like what is this? Some advanced mixers, even they have embedded devices involved in it. And robotics, I think, like nowadays robots are designed like the chips are embedded inside, so that when you whatever you want to do, that those you can achieve in the robotics field also with the help of embedded systems. And communication systems, as you know, those are all like involved in just one phone call of us, like how many layers of transmission it will go through. You will just initiate a call, but how many layers are behind that, and networking is behind that, and data like Wi-Fi drivers, Wi-Fi routers, and base station data centers, and your voice transmission protocols. So everything is involved in communication systems, and embedded systems are major part of that. And aerospace engineering, we already discussed the aircrafts, so they also use that. Industrial automation, as we said, like every industry requires automation for theirs, and Wi-Fi, Ethernet devices, and wireless infra. So these are all just some things which I have listed, but there are multiple stuffs which still we don't know. Like we cannot list here. Like it will not be enough here. You can just browse through that. Like where are all the applications of embedded devices? So embedded system design. So just I thought like you don't need to just speak over only whatever is available. So I'll, along with every slide, whatever I remember from my personal experience, I'll share those things also, so that you will understand better. Like I'll try my best to make you understand better, like what is happening in the industries, means what is happening in the companies here, and what is expected out of you, and what are all the opportunities you have, like which are all the fields you can concentrate. Like yeah, lots of fields are there which you can concentrate, so that, and everything is like one big ocean. So you can select your own interest of uh, layers, so that you can get into that kind of opportunity or job. And one more thing is like everything you can learn at any point of time. So it's not like you want to, if you have a particular mission, like, or if you have some particular motive, like you want to go inside this, you can start looking for those things now only, and what courses to be studied, and what and all the basics you need for that. So you can concentrate on that and you can go into that field. Or after engineering, you can perform a course where they have a embedded company's placement already. You can enter there also. We'll discuss those things later. So now let us come into this embedded system design slide. So generally, when a project comes, what people do? So product abstraction level. First of all, people will not just go into deep layers, like what will be the middleware, what will be the softwares, or what will be the drivers. They'll not go like that first, as soon as a project is received. So first of all, a project manager, he will be having an idea of all, like what is it, like the, if they ask for a product, supposedly we can say like for your understanding, we can give like a video product, like okay, just in all the shops, like they have like surveillance cameras. So they will just say like, I want some machine where I some the camera, there should be a camera, some IP camera should be there, and that should be capturing all the signals, like capturing all the images, and it should be sending to a system, and where I will be fitting the cameras in 4 places or 5 places, and I need like that signals to be captured in, and it should be processed, and it should be like clearly visible. Like I want this much resolution, I want this much frames per second, like what to say, I want this many frames to be going over, like in this many like that much fast, how refresh rate should be, and how it should sense, there can be some sensors also. So and finally I need like some 4 is to 4 cross 4 or 16 cross 16 uh, like images in one screen. In one frame I need to see these many images so that I can monitor the shop. So these kind of products also can come. And what to say, some different other projects like for their requirements, like video decoders, like they need like they will be giving some 8 or 9 inputs at a time, 9 video inputs with audio, and you have to do a decoding, video mixing, and finally I should see this display on my screen, and I should be able to select the inputs so that I should see that particular video and audio transmitting over my big screens. So these kind of different projects may come there. And image processing is also there, like it should be like just a customer comes in, like they should be doing a facial recognition or eye recognition, something like that. And it should be giving like this person's registration details, everything. Facial recognition projects will be there, and simulation projects will be there. So as soon as a project comes in, so product abstraction level, like managers will take all these requirements, and there are many standards. So people will say, suppose BT856, like those kind of video standards, they will say, and they will say, for now, I need this kind of security. So you should implement the security, what is the IEEE standards. Those are all like standards for securities. You should implement this on my products. So I need that level of inputs, and I need that level of processing. So, and I need to use this processor. So they will, based upon the requirements, the manager will decide the ASIC in the sense the chip what should be used. So nowadays, like in our smartphones, like MediaTek processors. Uh, Even all people are now seeing the, what is it, review videos, like phone reviews, this reviews, a laptop review. And like now Qualcomm chips are very famous, Qualcomm Snapdragon uh, uh, processors are used in the mobile smart devices. And and we know about those, but Qualcomm has designed like numerous number of chips for particular products. As we said, it's for a particular task. So there are some graphics processors, GPU cores. So these many processors, MediaTek is also doing processors, and ARM cores are there. They are using basic internally ARM cores and GPU graphics cores and design and SOC, so that the SOC will have all the capabilities of graphics, ARM computing capabilities, and image processing DSP core capabilities. So a chip will have all these capabilities. So coming to this line, so the manager will decide upon the input requirements, so that okay, we can have this processor, we can have this analog devices. This is a company where they have decoding devices, video, audio, driver chips. So we can go with this chips. We can go with this. Every product should have memory. So to which dynamic RAM memory we can go with. So all these should be designed, and they'll just give like a high level requirement, and then there comes the layout design, in the sense like they will put a high level layout like block diagram kind of stuff, where the processor will be there, and how the control flow goes, like from the processor. There will be the video input. First of all, the input is going through the video decoders, and then it is coming to the processor, and then it is coming to the output peripherals. So these kind of layout designs will be done, and that layout design has the schematics involved, which means schematics means like I cannot show an example of schematics here because almost mostly it will be confidential. But you have seen like circuit diagrams in your electronics science. So like the circuit diagrams, there will be many pages of PDF where they will be designing like, okay, one page will have that. So if suppose if you see my evaluation module like a big boards kind of, which will have multiple components over the PCB, like a motherboard. If anyone has seen a motherboard, there will be a particular processor, the Intel processor or Qualcomm processor, it will be in the middle and it will be surrounded by the components. So for that, first they will make a AutoCAD design, like hardware design, layout design, like how the line should be. Like they will connect the output lines of the processor to the components. Like they will draw the particular complete board system board in the uh, layout design. That will have even the information of everything of that embedded system, like even a small resistors value to the numbers, it will have everything. And that prototype development, in the sense like that will be like after the schematics is done, that will be given to the developing companies. Like if you give us schematics, they will design the board and give you back. So they will have PCBs. I think like board manufacturers, like mostly we have the China is the largest uh, manufacturing unit, where they do this embedded system, chips, devices, everything. Once we design, we go to the companies to get the development done, like the boards done, motherboards done for that, and then we receive the PCBs, like printed circuit boards, PCBs. We receive the boards, and then once the boards are received by our software companies, so what we will do? We have to bring up the boards. The board is a bare board which doesn't have anything. So all the chips, whatever we have designed, those are all embedded in that, and the board has come to us. Now we have to bring up the board. So now what should we do? So now when you see, you have opportunities in the design phase, like hardware engineers does that. Hardware engineers design the board schematics. Okay, if we connect this, how to connect? So supposedly, if you are connecting a processor to a decoder chip, or to any other chip, like whatever the some USB chip, or you are connecting to some what is it? Uh, some audio chips. So all driver those chips, if you are connecting it, you have to give the hardware lines. Someone raised hands. Karunya, any doubts here? Okay, let's proceed. So that hardware lines, like what is the interface you are going to use? So if there is a processor, if there is one more chip there, you have to communicate from your processor to that chip. So how will you communicate? You need some communication interface. I think you people will be knowing about this inter-integrated circuits, I2C, SPI, serial programming interface. So that chips that chip will have its own registers. So it will say, I am capable of doing this. If you give me some input, I will give you this output. So your desired encoded or decoded input, I will be giving to you. So, but you have to control me. The processor should control me. Like, what are all the settings you need? So you have to program that registers of that chip, and so that how will you program it? You need a communication interface, control interface, that is I2C or SPI. So these kind of whether you are going to use an I2C or SPI or GPMC, so many things are there, and how will those designing you have to design. So electronic engineers, ECE engineers are placed in that also. So in the hardware design, and then the prototype development. Once the board comes, we are the engineers. We should write some small diagnostic softwares. So there are some controlled IDE environments where IDE in the sense, like some. What to say for yours. You will have Xilinx, like FPGA, Xilinx IDE. From that particular IDE, you can contact your FPGA from your PC to the hardware. So like that, we have some IDEs where you can connect to the hardware. So once the board comes, you should first start with the small diagnostic softwares, like small, not like a big Linux drivers you are going to write. First, you have to check whether that board is working or not. So first you have to find out whether the communication interface. So once you control the once you are controlling the chip from the processor, So now you have programmed all the registers. So now it is ready. Like whatever data you give, it's going to give you the desired output. So the programming is done through the I2C and you have connected the data signals. So 8-bit data signals, 16-bit data signals, you are connected from the processor to the chip. So those designs, so you have to validate the hardware path completely. So once you are validating the hardware path, that is the diagnostic software which will do it. Just you can do a read write of some particular registers, like so that you have validated the control interface. Your I2C interface or control interface is validated. So through a small program, you are not going to completely program it. You don't need to know like what is the chip is doing. Like yeah, like all the fields have vast enhancements. So if you take a small chip, first of all, decoder, what we have to know from the basic is okay, how to read, how to write, and what is the like it is an 16-bit input or it is an 8-bit input, and or both you can give, you can change on the runtime, and what else, like it is what is the I2C, every I2C device will have an address, because in a board from the processor some 8 to 9 chips or more than that also will be connected. But one I2C line will be going to I2C communication interface will be going to all the devices. So you should know which device you are talking. So every device will have a particular address. So those designing is also done by the embedded engineers. So that device will particularly say like, okay, I am available at these addresses. You can assign these addresses to me. So like this you have to communicate with the devices, and then what happens, so this particular soft small diagnostics code writer, they are also like having opportunities, because how far you go in your advanced developments, anyways you have to start with your board diagnostic software development. You should be knowing like how to test like there are so many devices. You should be knowing like how to test an USB device, how to test an Ethernet device, how to test a memory device, how to test a audio device, how to test a flash device, like because there will be some flash memory in the sense like that is not a RAM memory, that is just a secondary memories, like flash memories, it will be there. So you have opportunities in these fields, and then once you have checked with the basic board softwares everything, uh, the hardware team will give the board to the software team, and now it is the job of the software team to bring up the board. So first level, like as we know, like even in the Windows or Linux, Windows or Linux is nothing but an operating systems. So wherever you go, the operating systems will first have a BIOS, or it's just a first small OS. You can say like small bootloaders. First, it will bring up the basic interfaces that is required for just bringing up the board. Like you should bring up the power management IC, means like there will be a power management chip in every embedded system, because without power nothing is going to work. So first you have to start with the power management IC, and there are lots of manufacturing companies for power management ICs, and you have a lot of opportunities in those kind of companies also, like PMIC design, and as I said, like so many drivers design. So we have vast opportunities in that also, and every chip manufacturer will have their own set of what to say softwares. They will support their own level of APIs or driver APIs. So they will give that set of APIs also. So in API, I think you will be not knowing. Maybe you can think like functions, their own supported functions. They will give that, and you have opportunities there. And example for Flash companies, or like supposedly we are using SD cards. So Micron and what is it? SSD softwares like Micron companies are there, and SD company is there. So there are many companies for flash devices also. And once the software team gets the board, they will bring up like Linux OS, like, or even if it is not an Linux or Android based embedded device, everyone will bring. Are you mistakenly raising hands or what is happening? Veena, did you raise hand?
Now, ma'am, I have one doubt.
Yeah.
Ma'am, you said that so many companies that we have opportunities. So, what are the basic skills we want to get an opportunities, ma'am?
Um, First of all, basic skills in the sense like whatever the if you want to go into that hardware industries, at least okay basic level of electronics, like what we will study is okay what is uh, like if you have some what is a circuits subjects are there. So if you want to go into the hardware industries, that circuit diagrams you need to understand. So if you connect like I forgot those impedance and those level because I'm into software and I have some 13 years like down the line from our engineering. But still, I remember like we have studied about our circuit designs. So if you want to design like basically like transistor logic, this logic like resistance, capacitance, like what does a capacitor do? Like if you connect it to a particular circuit, what does it does? So these kind of basics you should be strong with, like whatever your syllabus. La- when you are going to a campus placement, they are going to first ask for like your circuits only, like what is your knowledge in that, because the schematics design kind level like that will finally break down into the circuits like small circuits like this. What is the capacitance, impedance, like what are all those basic stuffs? Those basics you should be strong enough. And supposedly if you are like going through the software, so okay, let us assume like uh, you should be strong enough about like bit manipulations, like C language you should be very strong. And once you are coming into a C language, like you should develop your skills in a C language such that if you are writing one line, like you are writing one line like int I or int j or static int I, something like that. So what is the meaning of that? If you are writing one line, what it is doing in the background? So where it is getting stored, and like how you are going to write codings or softwares to do a bit manipulation, like and logics or logics, nor logics, like supposedly if you want, like I am my you are reading some packets, ethernet packets, or you're reading some inputs like this, you have got the data like this. How are you going to like because nowadays we are using many algorithms where you should be like you should be able to decode it, you should be able to write decoding algorithms. Okay, so now you want only the alternate bits, because yeah, for every 10 bits we are appending some crc bits, or we are appending some extra bits, padded bits, which you want to remove. And how we are doing the or logic, supposedly um, as I said, every chip will have a data sheet in the sense that will have some complete set of registers. So how will you write to that register? How will you read from the register? So that is bits. So if it is a register that is like 8 bit or 16 bit, you have to write some particular 1 to this field or particular 0 to this field. So you have a 8 bit, you have to pass, like you should know first, after reading that you should know what is there in the 5th bit or 6th bit. And you have to you have to, if it is like 1, or if it is like supposedly 3 bits, if the value is 100 by default, you have to write the setting of some 011 to that, and change it to this value and write it back to the register. So these kind of things will be there. So you should be knowing a bit manipulations in the C level languages, pointers, and pointer in the sense like again how we are using the pointers for memory access. So these kind of basics you should be knowing it to enter into the software or hardware, like that. And also if you are particularly interested on some topics, because nowadays advanced, like I could see some engineering courses for artificial intelligence, and there are some engineering courses now like AI, ML, and all. So, if you want to still enter those, you have to read the basics of all those things, at least theoretically, and you should get knowledge on that, so that they'll not consider you like okay, this they don't have like nothing, zero knowledge on them. They are still having some knowledge on that.
Thank you, ma'am.
Yeah. And here after we develop the softwares again, as I said, like now full-fledged drivers. So now the software team will write full-fledged drivers. So supposedly if you are writing a driver for a chip, if a chip supports some for 20 functionalities or 20 features, you should write the driver such that all 20 features are supported by your driver. So basic prototype development diagnostic software writing people will just write some basic coding, which it is enough to just test the hardware. We have tested all the lines of the hardware. We have tested the design, so that is enough. But if you are writing some advanced driver code, you should be writing like complete features of that device should be supported by your drivers, so that your applications running on the top should be able to use your driver to the fullest level, 100%. They should be able to achieve all the functionalities. And testing and validation, again testing and validation, that is also a big good opportunity, crowded area, like QA team, testing team means like you can, for testing and validation, you should have an idea like how a high level system works. Like okay, so if we are doing this, what is the high level, this is the input, this is the output. So if you are testing it, how will you test very efficiently, because that is the final stage, like after which it is going to the customer. You should think like a customer and you should test like vigorously and very stressfully, so that the customer should not face any issues while using your software. So
Ma'am, we can't hear your audio, ma'am.
sorry guys, some network issue. You able to hear me now?
Yes, ma'am.
Sorry. Able to see the screen now?
Yes, ma'am.
Thank you. And, okay, so we were in this testing and validation phase. So here also wide range of opportunities are there. Nowadays, people are trying to automate the testing completely, so that you should be knowing Python language. Like people are writing scripts or like it is like Bash scripts. Python language, like Python is a language which widely used to write the test automation scripts. So you can complete some courses on Python language, and you can go for those kind of opportunities. And as first of all, even as a developer, first we should be doing. First, you should be going in a testing team, which will give you like a very wide view of the product or very wide view of the embedded system, so that it will be very helpful for your development later. You should think in a customer point of view, so that it will be helpful, because finally that is the customer satisfaction is the greatest thing that every company should achieve. So testing and validation have also like large scopes. And next slide. Okay, so this has I think I cannot maximize, maybe I think you should be able to see it. So this one is the top to bottom level of an Android OS. Like, okay, so I just presented this because like you have opportunities in all these layers. So first of all, like, even as an electronics engineer, if you like, even if you are still interested in coding or like Java, something else, like whatever it is, so you have opportunities from top to bottom of this. So as you see, like system apps is there, and you can like the next layer, like Android layer, dialers, emails, those are like Android layers, and then Java API framework, Android framework, and then there are libraries. Like these libraries are required for this media frameworks, and 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 what else? So an Android runtime libraries. So these all these layers have a vast of opportunities there. It's not only based upon like Android OS on alone. It has like Android OS, Windows, like Linux, like all will be having almost many middlewares, firmwares, all kinds of layers. So if you see the hardware abstraction layer in this, so those are like importantly like to work with close to the hardware, like related to like our electronics domain. So these hardware abstraction layers are like supposedly if your hardware device can support what to say these many features, and a chip manufacturer will not design his chip only for a particular OS or only for a particular middleware or software. So he will design, like that is the standard in all the embedded devices. We have so many standards for that, like regulatory standards, like people should follow that. It should be compliance with 802.11 for ethernet, for IEEE standards. We have some standards who will design, like if an interface is designed, it should have all these capabilities, so that it can be used with any type of softwares or any type of upper layers, so that you are providing an abstraction layer of your hardware where they don't want to know about your internals, because they are like top layer people. They don't want to know about your internals. They just want like, okay, give me some function which will take this input, and finally I should get this kind of video buffer, this kind of data to my top layer. I don't want what you perform inside. but give me like this. So like that, it will talk to the hull layer. So for every device, so supposedly like okay, so you if you take an USB, and USB can act as like a USB storage, USB mouse, keyboard, different USB devices are there. Each one has its own particular supporting features and capabilities and drivers. So these kinds of supports should be provided so that your HAL can easily interact with the upper layers and down layers. So that is a common functions for all the upper layers, where they know okay, if a device supports the standard, it should be having this functions. So I can software company can plan to buy that chip, so that it will know like okay, this chip will have this support. We don't need to worry like whether it will be there or not. So every company or every chip manufacturers, device driver manufacturers, like they will be trying to match the standards. And here as you see, hardware abstraction layer is there, which will have like audio HAL, Bluetooth HAL, camera HAL, sensors HAL. So camera HAL will be there. So all the drivers beneath will have an abstraction layer. So which this abstraction layer will be visible to the top layers, so that they will easily communicate with the kernel and the drivers. So the Linux kernel, the down layer will have all the drivers. So the kernel gives place for all the drivers. The kernel in the sense like again the operating Linux OS system. So audio, binder, display drivers, keypad drivers, Bluetooth drivers, camera, memory drivers, USB drivers, as mentioned here, Wi-Fi drivers. So all these drivers will be here. And then comes the power management, in the sense like that's what we are saying, that's also a driver, but power management is also one of the important area. As soon as we grow on, as soon as the technologies are growing on, we want everything to be very small. uh, Form factor should be very small. If you are able to give a big feature, big capability in one small form factor, small device, that is appreciable. So the design cost is coming low, the components cost is coming low, and the product design above the chip, so that can be a very precise one, and it's attractive. So those kinds of stuffs are also like very important. On power management again, like how you are managing your like heat, and how you are how to say like if four cores are there, how efficiently you are using the cores. So supposedly if you are using one core, and if there is not necessary of using the other core in that scenario, you should power off that core, and when you need it, you can bring back it again. So these kind of like supposedly if you are using like very what to say, streaming feature or something else which needs like more resources should be used, so that time your frequency of the processor, or the frequency at which you are operating, it should be at a higher level. So you can design like that time you should be operating at a higher frequency, higher speeds, like that. But if you don't want, if you are using only a small one, and imagine these are not happening like some time to time, these are happening in even a seconds intervals. So for these seconds you should switch off, or you should power off your cores, or you should operate at a low frequency, and again you should immediately come back to the higher frequency based upon your performance. So that is also like power management design, which is one big growth area nowadays. Like people are trying to do power management both from the hardware side and also from the software side. And the next slide. So coming to the recent trends, uh, actually I gave more data before only. Like as soon as I saw the slides, I'm giving whatever the data I remember, everything. So from my personal experience data also. So nowadays, like artificial intelligence and machine learning technology, as I said, that's also recent trends, and the engineering courses are also available for that. And separate courses are also available, which you can study after your engineering, and you can get placement from those institutes itself. And ADAS, as you know, like nowadays, whoever is trying to buy a car, everyone is seeing for like ADAS features. like we need like advanced driver assistance. So that is also like recent trends in embedded systems. And nowadays everyone is moving to 5G, so all the communication network based systems, everything whatever is already there supporting 4G, now everything has to be supporting 5G. So all the systems has to be redesigned or what and all. If you have to meet 5G standards, there has to be particular developments in your hardware and software and security. So 5G expects all these things in your speed, in your clocks, like everything should be advanced. So that development is also a recent trend now. And military applications, like as we see, like so many new military devices or applications are there, which surveillance, military surveillance for improving like anything, your radars and everything has that embedded development in it. And cyber security, as we say, as far as we grow, we have more security threats. So anyone can hack the systems and anyone can track your data, like your communication systems, like they should have like too much of security. And your service providers, gmails, everyone, like everyone should have more security. So developments on security side is also required. Yes, we are seeing one by one down also. Multiple cores, like the keeping multiple cores in same SOC or in same product, so that you can support graphics, you can support image processing, you can support computing, so everything. So all components on a single chip. Like people are trying to come, like previously, you will be having the microcontroller separately, I2C controller separately, SPI controller separately. Like you will be communicating. It's like you will be connecting all those things in the hardware in a board. But now everything comes as a single chip. So in an SOC, layer by layer design, like you are having a you are having even a RAM embedded on your chip. Like your controller, your cores will be there, your cores will be directly communicating with the RAM. So layers of one chip has so many layer supports, so that all components are included in one chip. So your board design will become very simple. And the hybrid and electric vehicles, as we know, like now we are moving on with the hybrid cars, electric vehicles. So all has emirates and portable devices. You have that what is it? VR devices. We have that wearables, like where it's very easy, like to carry, and wearable laptops are there. So those kinds of embedded systems are there, and wireless technology, and that is very very essential and important stuff which is required for all the embedded devices. Because nowadays we don't like to carry wires everywhere, we don't need to connect with wires everywhere, so everything goes wireless now. And wireless brings in the cloud technology also inside, which is again one vast topic. So as I said, like SOC, system on chip solutions. So that is, you are able to see that SOC screen, right?
Yes, ma'am.
Okay. So ASICs. So if you see, you have some different ASICs provided by different vendors. So Qualcomm, Texas Instruments, MediaTek, everyone have their own ASICs. Even Cisco have their own ASICs for networking domain. Broadcom. So all these companies are having their own assets. So and people are buying from different vendors also. Like um, we as a Cisco still we buy some different Broadcom ASICs or chips, because if we feel better performance in those, we will buy that also based upon the performance and customer requirements. So those kind of developments are there. This just Wikipedia I gave, like you can just go and check, like Qualcomm Snapdragon chips, like how many SOCs they have. Based upon their requirements, they have vast number of SOCs for mobile separately, for development of industrial automation separately, for AI separately, and for vehicles like transportation. For those separately, they have so many different SOCs for specific tasks. And when you see AI and ML technology, as they see, like they are also used in many industrial automation stuffs, and especially in DSP, facial recognition and vision solutions. These are all like image processing and capturing. So collecting data is very big technology nowadays. Like you have to collect like, so how you can make your facial recognition so accurate and so perfect, and how can you sense with the sensors, and after capturing the image, like now we have so many filters and we have so many image processing techniques which will give you a very clear image outside, but your raw image will not be like that. So once you capture your raw image, how many layers of processing is going on? So that's like a biggest firmware development part, where you have so many layers for post processing, and finally you give the output to the display or to the user, which they will render the output. That like many professional cameras plus image processing, like facial recognitions, like finally how we are able to identify a face, how many points in your face you can take, and how you can learn from the data. So that machine learning, how you are making your algorithms to learn your facial data, so that you can recognize a face, like how like whether the eyes are closed or it is open. So those kind of systems are also available nowadays, like you are feeling sleepy or not. Yeah, the embedded systems can find out that, and it can alert you. It can give an alarm when you are trying to close your eyes, when you are trying to sleep, so that it will alarm, and finally it has gone up to a stage like it can apply the brake if you are not opening your eyes for some more than 1 or 2 minutes. So there are some advancements like that also in real time. So that image processing is one vast technology, image processing, image tuning, and thermal sensing, sensors. What are all the sensor developments you can give? What are all the sensors can detect? So these many developmental areas are there, and opportunities are there in wide range. And maybe example like here I have given for IoT is just an like you can monitor the operations in real time in a factory, and once you first time when you see like these you have monitored a system, and you have monitored like if the level of, if the heat level, example I'm saying, so if the heat level of this tube or this one, if it goes high, because you will have a temperature sensor continuously, and you'll be monitoring some machine in some place. So if the temperature goes high continuously, um, first time, after going the temperature has gone high, the system would have gone bad, and it would have stopped working, and the situation will become like you have to replace the complete chip or complete portion. But now what you can do is using the AI technology and machine learning. As far as you collect the data, you can design your algorithms like once this level and this levels go high, you try to switch off this. You try to switch off this device alone, so that it will not go completely bad, and you will not have that much wastage, or you will not have that much man work to repair it again. So because again, it should be going to the manufacturing hub. It should come back from there, and again you have to deploy that in your machine. So these are all like waste of time. But using AI and ML, you can avoid these kind of situations. You can detect the potential issues, and you can develop your algorithms so that you can avoid these kind of things. As I said, cyber security, again, securities are improved like anything, and now even from the hardware perspective, people are trying to give security. Like even for example, we can say whatever the network devices or switches from Cisco you have, you cannot power on as it is, like you cannot power on the device from the hardware itself. We have some signed keys or something, so that if you purchase those devices, you should get those devices in private from us, which you have to you have to bring up with those keys or signs or signatures. Only then it will allow you to get login or power on or use that device. Otherwise it's a waste for you, like you cannot even power on, and you cannot even get it and get anything from your device. So that much of security is developed. And while sending data, while receiving data, decoding in it or encrypting it and storing it, and again decrypting it and storing it. So these kind of security levels are available nowadays, even from the hardware and from the software. And that is also one kind of opportunity area where you can learn more on those security developments. You should be having a good coding practice. You should not write any memory leak codes. You should be very good in writing, like um, how to handle the memory. You are not leaking any memories. So those kind you can start now only to achieve your security levels. And the next one is automation. As I said, like there are wide range of automations available nowadays. Even in the testing point of view, see, supposedly, if you want to test something continuously for 100 times, test testing or something like that, who will sit manually and test nowadays? Who wants to do that? No, no one wants to do that. If you have some automated script, or if you have some something which will do it for you, like you just start running that script and you connect the system nearby. The test will start completely from the first. It will execute one by one all the test cases. It will test all the devices one by one, and from the output results, it will detect, okay, this test is success. Yeah, this is done. If it is failure, okay, it is failed, and collect all the data and write up. Even the coding is written to generate a web page. Like the results will be displayed very nicely for the user or in the production house. Like generally, developers, we will design and test only one board or two boards. That is those are all development circuits. We will design test only that much. Once that is completely tested and when it is going out for a production house, there will be thousands and thousands of boards getting manufactured, and no one will be able to test manually, and there will be many manual testing errors. Everything will be there. So everything is automated nowadays. So we have to test like completely, so that and it will be very, and you will have the wireless also embedded, where you can see the data, or you can collect the data and send it to some network or some IP, where you can store all the data, and whenever the people come, they will just come and open the data and check, okay, where and all it has failed. So that level of automation is going on. And one more this automation topic is about like um, particularly like AI and machine learning. Here the slide whatever I have given, like you can store the results everything in the cloud also nowadays. So supposedly if you are not able to be on the particular network from anywhere in the world, if you want to access the device, this automation plays a major role. And you can access any device from anywhere in the world using cloud technology. Again, that involves like many layers inside. Maybe computer science students will be more interested in those areas. And but that is required for embedded systems, which will improve your device capabilities. And again, as I said, there is nothing much new in this same wireless technology. But what are all the advanced wireless technology options you can provide? Every device, even from a small flash memory device to the big Wi-Fi or camera driver or camera device, everything has their own advancements. So even Wi-Fi is having more advancement in level of security, in the level of feature-wise flexibility, like how much it is very flexible to use in level of speed. Everything is improving. And as far as these are all recent trends are over, so now we can just see some glimpse, like if it is an embedded system, what are all you will be having in an embedded system? As we saw in the top, like product development life cycle, hardware. Hardware is a system which is consisting of the electronic devices So you have assembled many electronic devices to work together as a single unit for doing a particular task, and that is it is the one which is which will physically interact. Supposedly your processor or your SOC will physically interact with the memory, RAM memory. So whatever the software you are writing, that software will be loaded. It will be taken from the flash memory and it will be loaded on the RAM, and the means like our software is finally converted everything into an assembly language. Like finally everything is going to be in the machine language, and those all the machine languages assembly programming level. So all the assembly language converted code will be executed from the RAM memory. So it can physically interact and PCBs like motherboard, RAM, ICs, processor, microcontroller. So these are all the examples. And firmware. Firmware is the one which is specifically designed to read this, like to work with particular hardware. Firmware will work with a particular hardware, and uh, it will be like stored in a flash memory, non-volatile memory, which is like it will not go off with your power offs and power ons. So firmware is the one. Supposedly, if you have something like assume you are having a watch, smartwatch. So there is a firmware which is loaded on it already. Like whenever you reboot or reload a firmware, it is going to come up like always the firmware return is the same, and it will come up multiple times again and again, how many hours until the end of the device life. So that is a firmware. Previously there were like non-rewritable firmwares, but now they are like programmable firmwares. Now you can program the firmwares. So we know like we are receiving a firmware upgrade. We can program the firmware upgrade for your smart from your phone wirelessly. So those are all happening nowadays. So as I said, firmware is like they are using the memory like programmable ROMs, and the products are shipped. Means the watches or examples I'm saying, the products will be shipped with these programs and they run for ages. And as example, TV, washing machine, they are doing the job like whatever it is programmed already. The firmwares are already ready on it. So these are all also like opportunity areas like firmware development, which is also a one. And computer, the programmed one is BIOS. Like your motherboard will have a BIOS which will come up always. Once your computer goes into a recovery mode, you have crashed your system, your OS is crashed, you have to install OS again. But your BIOS should not be corrupted. At least the BIOS should be there. That firmware should be coming up so that you can enter the recovery mode and you can program your Windows OS again. So embedded firmware developers will write this program. And software. So here, software is a program that work on a wide variety of hardware. As I said, there are different drivers, means different softwares. Um, like that will get copied to a RAM, and before they can like they will be in the flash memories, non-volatile memories, and that will be copied to RAM and it will be executed. Now, as I said, operating systems. So mostly embedded devices will be laptops. Everything are using Windows, but our embedded devices will be using the Linux operating system because it's a open source. It's a free of cost. We don't need to pay for the Linux OS. So mostly embedded systems are using Linux OS or RTOS, real-time OS. In the sense, whatever is required, only those will be integrated into the OS. Like what is required for a basic operating system? Like how will you interact with the memory? How will you have an interface? So those kinds of basic things will remain in the OS, and all the features of a particular OS, it is not required for that product. So those products will use only RTOS, and all the applications that run on the system, like software meaning is OS, and if you have a system, what are all the applications running on them, and the down layer driver layers. Mostly I have worked more on the driver layers, and I have worked little on middleware also. And an operating system is a program which will that underlying that is an underlying software which will improve the efficiency, like so that whatever the upper layer will you are having it, it will interact with the drivers, and it will interact with the it will provide as an interface for the end user and the application programmers. So an OS does its job by abstracting the memory. So if you are having an OS, it will tell you, okay, I have this much of free space, means this much of RAM memory, this much of memory for my OS installments, this much of memory for your usage. So it will give your memory abstraction layer. It will give you, okay, this is the processing power. So I can run parallelly 8 processes, 16 threads, like multi-threaded environment nowadays. So it's like hardware is one, but we have multi-threaded environment. We assume like we can do 16 tasks at a time, which is not exactly true, but the 16 tasks are given as an abstraction by your operating system layer. So because the multiple processes can run simultaneously by sharing, because they are sharing the hardware resources on a time basis, and and they know, like, without affecting the other's context. It will share that. It is a very deep subject. If you want to know about these things, you should study the operating system basics. You can go through that, and that is also very important stuff which is required to be understood. On mainstream examples, Windows for an software, it's like Windows, Mac OS, that is an Apple iOS, and Linux. Linux has various distributions actually, like Ubuntu, Red Hat. So there are they all are Linux OS, but they have different still they are different distributions. So little differences will be there between them. And Android and iOS for smartphones. Android and iOS are for smartphones. So for embedded devices, still embedded Linux and free RTOS and this OSs are used. Examples. And coming to the interesting topic like device driver opportunities are like always available opportunities which you can like once you are into drivers, every platform, every embedded device will have definitely most almost like whatever the drivers required for those. So if you are working on a memory, if you have a knowledge of a basic memory driver, you can work on a NAND memory, NOR memory, like different memory drivers. If you have a basic idea of a video device driver, you can work on many video device drivers. So basic idea of any protocol or any interface you have, you can work on multiple devices of the same domain, so that you will be expertise in that, and you will have always opportunities for device drivers. So, and you will be always in the market. So, and main knowledge you require for this is advanced level of C programming. Complete C programming knowledge you should be having for this. And other programs like operating systems can interact with the hardware through this software. So operating systems are interacting with your down hardware through this software driver interface. They don't need to know about what is there on the down layers, what is implemented on the hardware. They don't need to know about that. They just want to know like what is supported and what it will require. Only that much information. Drivers will support the functions. That functions can be called from your operating system. So as I said, like there's a group of functions. Just operating systems talk to the hardware via this software interfaces. Some driver examples are memory, I2C, SPI, as I said, audio, video, repetition, and USB, flash, Bluetooth or Wi-Fi, these kind of drivers. This is just an example, like if you want to understand, like if you want to design an operating system, means that wireless cards, there is a Wi-Fi driver, and operating system should it is trying to do like turn the Wi-Fi on, turn the Wi-Fi off, and connect the Wi-Fi and disconnect the Wi-Fi. So all these should be supported by your driver, so that it can just call these APIs for the underlayers, and it can work on it. So as I said, every wireless card manufacturer, there are multiple companies who manufacture this Wi-Fi card. So they have to, if they if they want to support their device to this particular operating system, they have to give all these 4 APIs, 4 functions, where the operating system will understand, okay, fine. If I buy this manufacturer, all these 4 will be there. So I can use that Wi-Fi chip in my design, in my device. And these are all applications. So finally, the next layer is applications. Applications run on top of the device drivers and the operating systems. So the applications are top of these layers. So as you know, these applications are browsers, word processors, multimedia players. Like you have the, currently we are using the browser to attend the Google Meet. So these browsers will be communicating down the layers. First it will communicate to the operating systems, and the OS will communicate to the device drivers, and the device drivers finally will communicate to the hardware. Even in the application layers, still opportunities are more. Applications have wide variety of languages. So you have variety of language opportunities. So like not only C language, it has all the like C++, Java, web languages. So all languages you can if you want, if you have interest, you can finish and you can go for those openings. So these cannot talk to the hardware directly. That is like as I said. And the next layer is middleware. Middleware is like if you have two softwares, like you require a program like HAL. As I said, hardware abstraction layer is also a software, but that's a middleware which you can use. Like the top layers will communicate to the HAL layers, and the HAL will communicate to the underlying device drivers softwares. So this will connect two softwares. So like which is required as a piping between these two, piping work between these two layers. Like the data transfers, everything will happen through the middleware layers. Because if you just give your middleware support, you don't need to tell that what is there in your driver code or anything. So the middleware will just give a support like, okay, I have these APIs, but how have you implemented it? Those are all very confidential stuff which you cannot expose to the customers. So those kind of, so companies will provide the middleware, and the other softwares are only as a binaries, so that customers or others will not come to know like what is the implementation of those companies, so that it will be confidential always. That is required for all the companies, first of all, to protect their implementation data. So middleware examples, I don't know whether you will understand or not these things. So this middleware is like what I said, the middleware was like other example, and this middleware is Google middleware. Like they don't need to know about like what is if you suppose if you just browse like where is this Saravana stores, where is the Saravana stores, this location, so you will get the location, but that is a Google location. But how did you get that? From from if you just open Sarana Store's website, they will be having their location as a Google map, bitmap or location. They will be showing you in their website. How did they get that? They will interact with the Google middleware, and that is called the REST API from Google. And if you just ask for it, they will give you back. It will communicate with the Google server. The API will communicate. It will act as a middleman, and it will communicate with the Google server, and then it will give you back the data which is displayed in the any office website or anything, like if they want to show their location in their website using Google Maps. And another example is like in every phone we are getting like weather. What is the weather in which place? You can get on whichever place you want. You can just type like, I want to know the weather of Bangalore. I want to know the weather of Chennai or Wayanad or Kodaikanal. So everywhere you can get the because everyone cannot install a satellite, or everyone cannot install a, GPS or GPRS, like those things, like to get the information. But different manufacturers are giving the input. These should be read from their servers, and that should be displayed on our applications in the mobile. So that is also one more example of middleware. So coming to the last slide, like projects. So So these are all the projects. Like simply some projects I have listed here because I cannot list all the projects like whatever I have worked on. So hibernation, like whenever you put your laptop to a hibernation state, like every time you don't, so you hibernated, you closed your laptop, put into hibernation in the sense you are not shutting down, you have hibernated, almost all are powered off, complete power saving mode, it is there, but only it has to come up wherever you left off, it should come up with the same left off environment when it comes back. So and within minutes, so your time will be saved. You don't need to boot everything from the first of the system. So that support, hibernation support, we achieved in ARM 64-bit processor, and and I think ARM 64-bit. These are all like processors which are advanced processors which are used in the SOCs. ARM cores are used in all SOCs almost, and EVM development, like evaluation module development. Suppose Texas Instruments is coming up with a chip, Qualcomm is coming up with a chip, SOC. So they will develop a development module like by exploring all the features. Like my SOC can support all these features. They will develop a circuit board. They will develop an evaluation module. Like they by explaining the customers that how much they can support. From that you can pick back like whatever you require, and you can decide a separate individual board. So for the DVM development of Texas, I work with Texas Instruments for the DVM development and rear seat entertainment system. Like some companies, like one customer came with a like so entertainment system for their car, maybe like from the back seat. So that we supported HDMI inputs. So these kind of, and Android boot time reduction. Customers came with like Android boot time is very high, so they want to reduce it. So we can check like what are all the areas we don't want, and where and all we can which and all layers, driver layer, application layer, HAL layer, where and all we can reduce for time so that it can come up very fast. Maybe we did like from 1500 milliseconds to we did very less than that 500 milliseconds we came up. We were able to reduce that much. And power management, like how much you can achieve in power management, as I have already said you. And one project was like there was a drone, like GoPro camera, everything, and we have to develop a firmware upgrade module for that drone. Like, that was a big project. Even the complete drone software we worked on, but I was taking up the module like firmware upgrade module and sensor drivers. So I have worked on more sensor drivers like camera sensors and where I have to collect the data, I have to communicate with the sensor, I have to bring up a sensor module. So those I have worked on. Camera and video decoder drivers I have worked. Qualcomm I have worked with Qualcomm camera drivers and diagnostic software. As I said, like as from the initial stages of our work, we can work on the diagnostic software where you can. Where you can work on wide number of devices, like we can come to know about all the devices because minimal level of testing is required, but we will come to know about all devices. So that is also one thing. And finally, these are all the projects, so I can just list for your reference. And this is like just institutes which you can join for some courses after your engineering. CDAC, Vector Institute, J Spiders. So these some institutes we have hired like for our companies, like people have come from these institutes, so that after finishing their embedded courses, they are going for companies are going for placement to those institutes, and they are hiring people so that you can come finish any of your interest, any embedded course, and you can join companies. And references just I have listed here. Maybe I'll share this slide with your coordinator. You people can get these slides, and that's it about my presentations. So if you have any doubts or anything, you people can ask now, or that's it about the session. Thank you all.
Ma'am, can you please share some of the works done in Cisco?
Sorry?
Ma'am, can you please share some of the works done in Cisco industry?
Cisco. Actually, whatever I shared now, uh, these are all like at least okay. It is like little understandable. Like Cisco work. How can I say is like those are. I am working in the platform team, like very down layer. Cisco is like multiple domains and multiple areas are there, where starting from the pure software until down the lane of the hardware, they have everything on them. So for me, my layers are like Cisco works mainly on the networking data centers and networking layers, everything. So um, Cisco platform team, I am part of a platform team where I work like uh, routing the data, like data centers in the sense like so many requests for Ethernet layers are there in that routing. Okay, every company will have their own data centers. Okay, so all data centers are supported by Cisco kind of networking companies, and what to say like Cisco and one more company. What is it? Um, I forgot its name. Like, there are some more competitor companies there. These companies are providing networking support, data center support for all the companies. Even our National Engineering College will have their own data center where all the, because they have to provide like all the labs, everything, your login inputs, everything should be stored in data centers, so that when you come and retrieve it back, you should be able to see your login stuffs. You should be able to see your work, saved folders, everything. You have to come back and access it. So you have to develop that switches. So that is the basic of Cisco embedded platform team. Like the advanced switches are developed, and and what to say like those switches will have that Ethernet ports, their own ASICs, and their own processors. So I am working on like Gunston say as Linux OS, and and the drivers like not even drivers, Cisco proprietary firmwares, and not drivers, Cisco proprietary firmwares or middlewares, and driver layer is also there. Maybe possibly we can work to and fro there like that. Those kind of firmwares and operating system, like basically Cisco has different operating system, so not Linux. So that kind of OS jobs and networking job, sorry, this driver jobs I am working on. Yeah, we can. I cannot make you understand more than that. Different kinds of processes are there.
Thank you, ma'am. Ma'am, if you are an HR means what do you expect from student side, ma'am?
HR's expectation is generally different. Like that depends upon the work mode. So as I said, for freshers, you people Cisco may not expect anything much, like because they have to give training on what basics required for Cisco from the software engineers. So as I said again, your operating systems knowledge, your C language knowledge, and if you want to go into the networking side of Cisco, like CCNAs and those networking, like how um, what is it, how Ethernet is working, like how like data packets are sent to and fro, how your data communication is going on, control systems. So these kind of information, like if you want to study the CCNA course, so those kind of stuffs you can for that you have to study those kind of stuffs. For platform team, again as I said, like very strong knowledge in C, and strong knowledge in memory point of view of C language, like how the memory is accessed, and how what is happening during compiling of your C language, compiling of your C program, stages of compilation, and while finally creating an object file, how you are saving your data. So these kind of information and bit manipulations you can be strong on as a student. And I am, I don't know like what changes in syllabus you have gone with. So related to these topics, whatever the changes you have, maybe syllabus you have, those also can be strong on. Data structures, that is also important, like queues, stacks, threads. So and thread-wise knowledge, operating system knowledge, you should be strong on.
Thank you for your valuable words, ma'am.
Yeah, sure. Anyone else have doubts? Or anything apart from that you want to ask me? Okay. And one more thing I want to inform you is like, so if you want to, if you are pursuing any course or not, like you have knowledge, so the company is listed or whatever we have I have given, you can just go to their website. Every companies have their own website, and from the careers page, don't hesitate or don't like feel shy or nothing. Like if sometimes you can even see a job opening like software engineer 0 to 2 years, 0 to 1 years, like that kind of opening. You don't need to miss that, right? So you can directly go to the offers page. Don't think like we cannot get even Amazon, Flipkart, everyone is having the similar devices option. Wipro, TCS, everyone is having the platform team openings, EC electronic openings, Tata Elxsi. So all these big companies are also having embedded openings, which you are thinking like they are not purely software. So you can try for all these companies. Career page, go and boldly apply, and be basic with your, be strong with your basics, and you can try for those companies. And the list of companies, whatever is listed in the links, even there also you can try from the careers page. You can go and apply for them. If you have opening like for freshers or 0 to 1 years, like those kind of, or you can finish a course where you will get some good knowledge of embedded thing, and you can just 6 months course also should be enough, and you can easily enter any embedded company in Bangalore, Chennai. There are wide range of openings for this. Yeah, and that's it from my side. Any other questions? Apart from Veena, can anyone tell? Is it like feeling very sleepy, or was it good? Sorry, actually, it's like very long time. I didn't do anything like brainstorming like this, so it may be um, I didn't say in order or maybe like that. But was it very sleepy, or as at least it was it useful to you? Open up. It's okay, no? Tell me. I see boys are also there in this call, man, but no one is speaking about.
Yes, anyone, anybody having a doubts or anyone having the queries?
Who is that Shankara Narayanan? Can you tell me, like, was it somewhat useful to you? Hesitating to talk? Fine. Well and good. Let's finish the session. Then,
Thank you, ma'am. Thank you for spending this much of time for us. Thank you so much.
yeah, fine. Thank you.
Yes, invite Ms. Divya to present the vote of thanks.
Sure. And Jayanti, I will try to share this presentation if anyone requires. Maybe I'll share this.
Sure, ma'am. Ma'am, if further, if we want to contact you, then how can we, ma'am? Through mail or through LinkedIn?
Yeah, to mail or WhatsApp, whatever you did in the same way, you can contact.
Okay, okay, sure. Thank you, ma'am.
Thank you.
Good afternoon to everyone. As we come to the end of this esteemed gathering, I would like to extend a heartfelt thanks to all those who have made this event a resounding success. We are truly grateful for the support and contribution
that have made this occasion memorable. First and foremost, I would like to express our deepest gratitude to our esteemed chief guest, Mrs.G. Vaishnavi. Thank you for gracing us with your presence and sharing your valuable insights with us. Your journey and accomplishments have served as a great source of inspiration for all of us. I would also like to extend our appreciation to the organizing committee and event volunteers who made this event a great success. A special word of thanks goes to your faculty and alumni council members who have played a crucial role in the planning and coordination of this gathering. We would also like to express our gratitude to the participants and attendees who have joined us today. Thank you once again and hope we see you all in future events. Thank you, ma'am.
Okay, thank you so much.
Thank you, ma'am. Thank you.
Yeah.
Yes, ma'am.